Hey guys, today we are going to look at algebraically finding domains of functions. So we have already introduced how to find domain and range if you're looking at a graph, and you can always use your graphing calculator or Desmos, the graphing website, to help you graph functions and then estimate the domain, but sometimes there's an easier way. So we already know for some of our function families, linear, quadratic, cubic, absolute value, and exponential functions, the domain of all of those function families is automatically all real numbers. And you can tell that when you're looking at their graphs as well. However, there are three function families that we're going to look at today where their domain depends on a specific function. So like not all radical functions have the same domain, not all logarithmic ones have the same domain. And so we're going to use algebra to determine exactly the domain of these graphs, or excuse me, these functions, so that way we don't have to estimate using a graph. All right, so for logarithmic functions, first a little bit of review. There are two parent functions that this graph has, this logarithmic function has. The first is just if you have a common log, so you'd have some sort of log and then a little base number of x, or the other parent function would be the natural log function. Okay, so those are your two parent functions. This graph has a vertical asymptote, which is a dotted line or a dotted vertical line your function approaches but never touches. This one does specifically at, let's make that a little prettier, at 0. So that means my graph is going to continue down for forever, and it's never going to touch this axis. So the domain of this function would be everything, all x values such that 0 less than x less than infinity, or another way to write that would be all x values such that x is greater than 0. And that's because your typical logarithmic function will never touch 0. This asymptote will go everywhere to the right, but it will never hit 0. So what this means for us is that whatever is inside parentheses here, so natural log of something or log base b of something, as long as that's greater than 0, our function is going to be defined and our domain will be set. So we're going to walk through some examples of logarithmic functions. So for example, if I wanted to determine the domain of the natural log of 3x minus 4, I know that as long as whatever's inside my parentheses is greater than 0, my function will be defined. So we're going to set that up that inequality and then solve it. So I'm going to take what's in my parentheses, 3x minus 4, make it greater than 0, and then I'm going to start solving. Add 4 to both sides. So I got plus 4 here, plus 4 here. I'll end up with this equation, and then divide both sides by 3. And then I have this inequality. So now I know that as long as x is greater than 4/3, that would be my domain of this natural log function. So as long as x is greater than 4/3, my logarithmic function will be defined, and then your domain is set. So then we would write the domain as the set of all x's such that x is greater than 4/3. We can do the same thing for a common log as well. So log with a base of 4, something like that. As long as whatever is inside of the parentheses is greater than 0, my function will be defined. So we can do the same thing. So I have negative 2/5 x plus 10, make it greater than 0, because that's what's inside the parentheses. I'm going to subtract 10 from both sides. And that's how I end up with this next inequality. And then I'm going to divide both sides by negative 2/5. I also like to think of it as multiplying by negative 5/2, multiplying by the reciprocal. So negative 5/2. Remember, when you multiply or divide by a negative number, which we're doing here, we flip our inequality. So my inequality was x greater than, now it's x less than. And so this would make my original logarithm, what's inside my parentheses, greater than 0. If x is less than 25, that makes this work. So as long as x is less than 25, my logarithmic function is defined, and then the domain is the set of all x values such that x is less than 25. All right, and now that we've walked through those first two examples, let's try one. If you want to go ahead and pause and try it on your own, you feel free to, so go ahead, pause. And then we continue. So let's go ahead and work through this one. So I have a logarithmic function. So I know that whatever is inside my parentheses, as long as that is less than zero, oops, not less than, greater than zero, excuse me, that my logarithmic function will be defined. So I'm just going to start solving this. So I got 16x minus 8 greater than 0. I'll add 8 to both sides. And then I have 16x is greater than 8. And then you can either divide both sides by 1/6, or I like to multiply by the reciprocal. So I'll multiply both sides by 6. And I get x is greater than 42. 8. Got it. Simple math sometimes, you know? So then if I'm going to actually write out my domain for this logarithmic expression, the set of all x values such that x is greater than 48. Excellent. So that's how you handle all logarithmic equations. Next, we're going to move on to radical functions. So here's a radical function, and the parent function that we work with for this radical is y equals the square root of x. And for this guy, it says what's the domain of this function. So there's an actual point on this radical function. There's a point right here, and this is the most basic radical function. And so the domain of this graph would be the set of all x values such that x is greater than or equal to 0. And so then as long as I make whatever is underneath my square root greater than or equal to 0, then our function will be defined and our domain will be set. So let's walk through these two examples. So I have determined the domain of this radical equation. So I take whatever's underneath my root and I make it greater than or equal to 0. And then it looks like I add 19 to both sides. That's how I get this equation. And then I divide both sides by 2. And that's how I get this inequality. So then this is what makes my radical greater than or equal to 0 underneath the root. And so this would be what my domain is. So as long as x is greater than, oh, there should be an or equal to symbol right there. 19/2, my radical function will be defined, and then your domain will be set. Here, fix this typo real quick. There you go. All right, let's look at a slightly trickier one. So this one is a little bit trickier because we have a quadratic equation here. And so we know that as long as our quadratic that's underneath our radical, right, that's the tricky part, is that you have an x squared plus x minus 6 underneath the root. As long as I make that greater than or equal to 0, my equation will be solved. And so you have to go a little bit old school with this. If you have a quadratic, x squared plus x minus 6, and then you have to solve a quadratic, you have to factor. So little quick refresher on factoring. If you remember, it's what multiplies to your AC value. And our AC value here would be 1 times -6, so that'd be -6. And then it's what adds to your B value, so adds to +1. So what are two numbers that multiply to -6 but add to a +1? Well, that's a 3 and a -2. And so then that's how we get these factors. X plus 3 is one of the factors, and x minus 2 is the other factor. I said we run into a little problem. It's not really a little problem, but first you have to separately set your x plus 3 and your x minus 2 equal to 0, right? Because you have two factors, so there are two ways that this thing could be greater than or equal to 0. And so then if I subtract the 3 over, then I get these as my solutions. So x equals -3 and x equals 2. The domain for radicals that have quadratics is going to include two pieces. The first piece is that numbers less than or equal to our lowest value will be in the domain, and then numbers greater than or equal to our highest value will be in the domain. So this is all of the x values less than or equal to our lowest solution, and then all the x values greater than or equal to our highest solution. Those are in the domain of this radical function. All right, we're going to try one of those because it's a little tricky, so let's go ahead and we can do that. So I'm going to take what's underneath my root. I'm going to take my x squared plus 12x plus 20, and I need to automatically make that greater than or equal to 0 because this is a radical function. Then I'm going to factor this because it's now a quadratic in my inequality that I'm trying to solve. And so again, I'm trying to figure out what multiplies to my AC value and then what adds to my B value. So AC is 20 times 1, so 20 right there, and then it has to add to 12. So what are two numbers that multiply to 20 and add to 12? Well, I think of a couple numbers, but this one, 10 and 2, seems to work out quite well. So then my factors are x plus 10 and x plus 2, okay? Then I solve them separately, so I have x plus 10 equal to 0 and x plus 2 equal to 0. All right, so x equals negative 10 is one solution, and x equals negative 2 is another solution. So then my domain is going to be all the numbers less than or equal to my lowest value. My lowest value here is negative 10, so let's go right over here. We'll write our domain, x such that. So all the values, all of the numbers less than or equal to my lowest value, which is negative 10, or all of the numbers that are greater than or equal to my highest value, which is negative 2. There you go. That's gross. There we go. That's your domain for radical functions. So they're easier, like I said, if there's just like a, 2x minus 19 under the root. But if you have a quadratic, then we have to bring back the factoring a little bit. All right, let's really quickly look at our last one, rational functions, and I think this one is probably one of the easiest ones. So a typical rational function is 1 over x, that's the parent equation for it, and the domain of this function is all values for rationals. The only thing that you're not allowed to have is you're not allowed to have zeros in the denominator, because as you can see, this rational function has an asymptote there. So the domain of this original function is all values of x such that x is not allowed to be 0. So we make whatever's in the denominator, we don't let it equal 0. Okay. So for our first example of that, we take what's in our denominator. We're going to set it equal to 0 and solve for what will not be allowed in the domain. So that's what I do in this first example. I take what's in the denominator in the bottom, I set it equal to 0, and then I'm going to not allow this to be in the domain. So x plus 15 equals 0, subtract 15 from both sides. So then now, because this would make the denominator 0, I don't allow it to be in the domain. So there's my domain. All values of x such that x is not allowed to be negative 15. Again, you could have a quadratic that you work through this way. The only thing is that you'll have to factor as well. So x squared minus 7x plus 12, I make that equal to 0 because I'm going to figure out what's not allowed. If I do my AC that I multiply to, I'm running out of room over here, but we figure out what multiplies to 12 and adds to negative 7, and they figured out that was negative 3 and negative 4. So that's how we got our factors. Separately set those equal to 0 and solve for those solutions, and then because those would make the bottom 0, we don't let them be in the domain. All right, let's do this last example here. So we take whatever's in the denominator of a rational function, very sloppily, set it equal to 0, and then we figure out what multiplies to 90 and adds to negative 1. Oh, geez, let's think about that one for a second. So it's got to be like 30 and 3, 45 and 2, 10 and 9. Oh, it's got to multiply to negative 90 too. Careful. So that would be, I thought of that, negative 10 and a positive 9. There we go. That's how we get that negative 1. I knew there was something that we were missing. So my factors are x minus 10 and x plus 9. So then I separately set those equal to 0. And I'm figuring out what's going to not be allowed in our domain. So x equals 10 and x equals negative 9. So all x values such that x is not allowed to be negative 9 or 10. And that is your domain. If you have any questions about finding domain and range, feel free to let me know. But other than that, go ahead and get started on some practice.